Hey everyone, and welcome. When you use your favorite apps and they just work, or you see these incredible insights pulled from huge amounts of data, it kind of feels like magic. But it's not. Behind all of it, there's some hidden machinery, a powerful idea that makes it all possible. So today, let's pull back that curtain and see what's really going on.
So what is it? What's that invisible engine driving everything in our digital lives? From the code a developer writes, to the data that powers business, all the way to the AI that's changing our world. What's the secret?
Well, the answer is surprisingly simple. It's pipelines. Yep, that one word describes the automated factory floor for pretty much all of modern technology. Okay, so here's our game plan. We're going to start with a really simple analogy, the good old assembly line. Then we'll see how that exact same idea is used to ship software, to refine raw data, and even to build artificial intelligence. And we'll wrap up by looking at the real reason we do all this and what it means for the future. All right, to really get this, we've got to start with something we all understand, a classic factory assembly line. Honestly, it's the perfect way to think about how pretty much every digital product gets made today. Just think about it, right? An assembly line takes some raw materials, pushes them through a bunch of automated steps, checks for quality along the way, and pumps out a finished product. And it does it reliably and in a massive scale. Those words, automation, quality, and scale, that's the whole point. So we can boil this down to a super simple three-step model that we're going to use for everything today. You've got your raw materials, you've got your process, the assembly and the quality checks, and you've got your finished product. Easy enough, right? Okay. Now let's see what happens when we apply this to the digital world. First up, software. This is the assembly line for shipping code. In the tech world, we call this CI/CD. That's continuous integration and continuous delivery. And here, our raw material isn't steel or plastic, it's code, fresh from a developer's keyboard. And check it out. Our assembly line model maps over perfectly. The raw materials, that's the code from the devs. The process, that's where the pipeline automatically builds the code, runs, thousands of tests to find bugs, and then packages it all up. And the finished product? A working app delivered right to you. Now there's a really important little difference here, and it all comes down to one question: who pushes the final button? With continuous delivery, the pipeline does all the work to get the app ready, but a real person has to give that final okay to release it. But with continuous deployment, whoa, if all the automated tests pass, the code goes live to users instantly, no human involved. You've got to really trust your tests for that one. And that's the thing, right? This isn't just about being fast, it's about being safe. So teams use these really smart strategies to lower the risk. You've got rolling updates, where you slowly replace the old version, or you could do a Canary release. Give the new stuff to just, say, 1% of your users first and see what happens. And for ultimate safety, blue-green deployments let you flip a switch and move everyone from the old version to the new one in an instant. Rolling back is just as fast if something goes wrong. Okay, let's swap out our raw material. Forget code for a second. Now let's talk about data. Every click, every like, every transaction, it's all raw, messy information. And it's basically useless until it's been refined. And what do you know? Our model works again. The raw materials are all that chaotic data from a million different places. The process is where the real work gets done. You extract it, you clean up the mistakes, you filter out the junk, and you transform it all into a nice standard format. And the finished product? Beautiful, clean data, all ready for analysis in a data warehouse. A really big shift in the data world has been moving from what we call ETL to ELT. It used to be you had to do all that transforming before you put the data in the warehouse, but modern cloud warehouses are just so ridiculously powerful now, it's often way easier to just extract the raw data, load it all in, and then transform it right there, using the warehouse's own massive power. All right, on to our final and maybe most mind-bending pipeline. The raw materials are still data and code, but the finished product this time? It's not an app, it's not a report, it's a trained AI model. It's literally a piece of manufactured intelligence. 85%. Just look at that number for a second. What on earth could that mean when we're talking about AI? It means that an absolutely staggering 85% of AI projects never actually make it into the real world. They fail. Why? Well, because building a prototype on your laptop is one thing, but actually deploying it, monitoring it, and retraining it reliably, that is a whole different ballgame. And that huge problem is exactly why MLOps, or machine learning operations pipelines, were invented. And our trusty assembly line model holds up yet again. Raw materials are the data for the model to learn from, and the code for the model itself. Now, the process is pretty unique here. The model is trained, its performance is evaluated, it gets a version number just like software, and then it's packaged up. And the finished product is a live AI model out in the wild, making real-time predictions.
And this shows the whole life cycle perfectly. See, it's not a straight line. It's a loop. It's a circle. You build the model, you train it, you deploy it. But you can't just walk away. You have to constantly monitor it. Is it still accurate? Is the world changing? And that monitoring data feeds right back to the beginning, kicking off a whole new training pipeline. It's a process that truly never ends.
Okay, so we've looked at pipelines for code, data, and AI. On the surface, they seem pretty different, but they're all built on the exact same foundation. So let's zoom out. What's the real, ultimate goal of building all these things? It's really easy to look at this and think it's all about speed, just going faster. But that's just a happy side effect. The real goal is reliability, consistency. It's about building quality control into every single step automatically. It's about making that feedback loop so short that you know if something's wrong in seconds, not weeks. When it comes down to it, it's about having fewer surprises and a predictable, secure way to build great things. So, after all that, what's the big takeaway here? What's the one thing to remember about this whole pipeline concept as we look ahead? Here's the most important thing. A pipeline is so much more than just a tech tool. It's a mindset, it's a philosophy, it's a repeatable, quality-focused way of thinking about how to build anything in the digital world so that it's reliable, so that it can scale, and so that it's high quality right from the start.
And that kind of leaves us with one last question to chew on. If these pipelines are the engines of technology and automation is their fuel, what's next? What new, incredible things that we can't even imagine today will these assembly lines allow us to build tomorrow?